Our next speaker, Brent Tubbs, comes from Palo Alto, United States. He's the Deputy Technical Director at YouGov. It's an online market research company. He's the author of Velociraptor and Metal projects. Brent will talk about using pure Python and pure Postgres in real-time web apps development. Please welcome Brent Tubbs.
We've had a very impressive group of speakers so far. It's humbling, and I hope to be able to live up to that level of quality. As Tomek said, we're talking about how to make a web app that is real-time. We'll talk about what that means with a very simple stack using just Python and Postgres. We're going to do this in phases. First, I want to talk about why. Why would we build a web app this way? And secondly, how can we go about doing it? Why would it be in real time? Why would it be in Postgres? And why would it be in Python? And we have to take one slide to say, what does real time mean? Because there is a branch that's really called real-time programming, where every computation result that you produce has to come in within a specific deadlines. This is embedded systems primarily, but it can also be something like a chess program that has to get its answer in within 30 seconds. We're not talking about that. We're talking about what's soft or near real-time, where like a chat room is a good example. If you've used Trello, that's a good example. Google Docs, where you see the other person typing. Most of our web pages don't do any of that, though. They're in this third category of not at all real-time. And just refreshing is not the answer. Why do we want to build them this way? The answer to that is really about the user, because there's a class of applications where things are changing out in the world or even just in your database, and the user is interested in those changes. And if we can do it, it would really make the user's life better to let them know as soon as the thing happened, instead of making them refresh the page, or just them maybe never knowing because they closed their tab. So what kind of apps are we talking about? If you are looking online at like tutorials or people's little demos of how they got some WebSocket app working, they tend to either be games or chat rooms. But there's a lot more examples of where this is useful that you might hit in a more enterprisey scenario. Monitoring is one that we've had to do at work. Automation is a huge one. And maybe you want to build some kind of tool for teams to collaborate together. You want to build your own Trello or the next better kind of thing like that. All of these benefit hugely from having your interface immediately tell you something happened instead of making you keep asking it. Why would we use Python for this? There are alternatives out there. The Go ecosystem, the Node.js ecosystem especially, really emphasize streams of data and being real time. Python has its own advantages, and the one that sticks out to me most is fun, though there's more than that. Why would we use Postgres? There's some similarities with why we use Python. It's very mature, not very surprising. It also has some things that are very different. Whereas Python is dynamically typed, Postgres can enforce great strictness on your types. I think that's actually a nice compliment. But it's also really fun to use, at least in my experience. This part of the title might take more explanation. Why do I say just Python and Postgres? If you go online, you do a Google image search for Python WebSockets, you will get back diagrams that look like this. And people make these diagrams because when they tried to create some application that would update an interface in real time, they found they had to use this framework and maybe that other framework, some other backend that can stream the events, and maybe they had to plug into some specific thing with Nginx, and the stack gets complicated. And that is a lot of weight to carry around. It is a lot of, not just weight to carry around, it's kind of a big hurdle if you just want to try something out and experiment with something on the weekend, or it's just like some weird side app that you have to make because the business needs it, but it's not your main product. those things are never going to warrant all of the sysadmin support that is required when your stack looks like these things. I want a stack that looks like this, where you can just say, hey sysadmin, I need a Postgres database. I'm going to write the rest in Python, we're good. So let's talk about how we can do that. We're going to build, you may be familiar with this to-do application that like every JavaScript framework out there implements this app, a to-do list, so you can kind of compare the JavaScript frameworks. Well, we'll take one of those, stick a Python and Postgres backend on it, and make it so that one person's changes are immediately reflected in another person's browser. And we're going to do that in a few different levels in a minute. We'll do the database layer, we'll show you the Python layer, and we'll show you the top layer. But when we build this out, there's some things we're going to need. We want a REST API to allow just the basic CRUD of saving things and getting them that mediates between the database and the browser. We want WebSockets. That's what we're going to use, at least in this example, for the streaming. There are some other options. You could do long polling. There's a thing called server-sent events, but WebSockets are the simplest solution that I can see. The UI itself is not going to be built in Python. It's going to be built in JavaScript, because if we are just sending little events saying this to-do was completed, that one was created, we don't want to send like a whole page of a Django rendered template or something. We just want to send a little event with a tiny payload, and all that change to the interface layer is going to happen in JavaScript. So we're going to be using either some framework or something JavaScript-based for the UI. And that implies we need also some tools that are JavaScript-based at build time. Maybe we're installing packages from the rich JavaScript ecosystem out there with NPM. Maybe we're compiling JavaScript together. So at build time, we're going to have both some Python stuff and some JavaScript stuff going on. There's some things we don't need that maybe we're more accustomed to using when building applications more traditionally in Python. We're used to having some templates on the server side, some form libraries, an ORM. We're not going to need any of that because our UI is going to be purely in the browser, and our data model is simple enough. Our app's going to be simple enough. We can just avoid the ORM thing entirely. We can write SQL. So for this app at least, we're going to throw out the framework. We're going to take a library that its pronunciation is challenging. It depends on which continent you're from. Americans pronounce it Werkzeug. Here in Europe, Werkzeug is probably more idiomatic. We're going to use that and just a tiny bit of code on top, and you kind of have your own like 100-line micro framework. Plain WSGI middlewares can give us things like sessions and auth, and because we're going to need a whole lot of connections open potentially at once, we don't want to block, we don't want to use up a ton of threads. I like just throwing in gEvent to give me that, all those open connections at once, pretty much for free. And as we build up this micro framework, I have some personal biases. If you check out the app and you look through its code, you may wonder, why did you do it this way, not that way? If it's any of these points, it's just because that's the way I like it. There's not at least any objective argument I'm going to try and make for why this is better, but it's the way I like to build an app. So as I said, we're going to do this how part in 3 steps: the Postgres layer, the API layer, and the UI. Postgres, of course, is a SQL database, and this is what our table is going to look like. It has just 4 columns for our to-do items, and only one of them do we need to supply when we create a new one. That's just the title. All the rest can be automatically created by the database, so that's nice. Postgres, you may not know, has a pub sub built in. So it takes the SQL standard and it adds 2 commands, listen and notify. So if you have a couple windows open and you type listen in one and you give it an arbitrary channel name and you type notify in the other, then back in your first window you can see the message coming across. Postgres also, as of a couple versions back, back adds some nice JSON functions. We can take a row and just cast it to JSON and get that back in our Python code. And this is part of what makes it easy for us to avoid the ORM, because we just work with the dictionary. And that's if we even need to inspect the payload, we can just work with the dictionary. If we're just passing it out on the API, we don't even have to look at it. And that happens, the little bit of JSON magic we're using from Postgres happens right there. We say, take this to-do item and cast it to JSON before you give it back to us. Postgres also has triggers built in. They, I think, modeled this after the way Oracle works. And you can say, every time I insert a row, insert one of these to-do items, or I update it, or delete, but that makes this example more complicated, as it says in the footnote. You can have a little function that runs. It'll give, and Postgres will give your function both the old version that's being overwritten or deleted or whatever, and the new version. Well, here, we're just saying, take the new version, cast it to JSON, and send one of these notifies with that whole payload, with the whole row. That's pretty much the story on the Postgres side, and we'll see how to tie that to Python in a minute. This is another page of caveats, though. Postgres is not going to scale up to thousands of people connected and listening to these streams at once. The number of open connections you want on Postgres is probably in the low hundreds at most. And if you need to scale past that, then your stack gets a little more complicated, but at that point you can probably afford it. The payload size on these notifications is also capped. For a to-do item, 8,000 bytes is more than enough, and we ensured we would never trip that by limiting the size of our titles to 512 bytes. And all these other columns have a bounded size, so we know we're never going to be over 8,000. So we go up to the Python layer. Python can subscribe to these notifications out of Postgres. This example is just barely tweaked from one given in the PsychoPG2 docs. It kind of gets down to a layer that maybe we don't hit very often. It's using the actual select module and blocking on that. I have written this snippet in so many projects so many times that last week I decided to wrap that in a tiny library. This is like, I think it came to exactly 50 lines of Python, but now it's something I can just import and get a nice iterator over every notification coming out of Postgres. If you run that script I showed, or either of those last two, and then you're back in your Postgres window and you send one of these notifications, you immediately see it printed just like that. And that is the story from Postgres. How do we go to the API layer? How do we tie these things into WebSockets? And how do we make them play nice with our REST API? With REST, there's a core that I think we all kind of agree on, and then there's some fringe stuff that everybody argues about. But the stuff that's filled in on the right-hand column here, I hope we all could pretty much agree on. If you want to create a new thing, you do it with a post, and you do it to a path that looks like that, and similar down the list. This shouldn't be too controversial, but where do our streams go? The answer in kind of the leading WebSocket implementations out there, like Socket.io, is you have some path that's designated in your API, like called /socket.io/. And within that, you have different channels, and they have their own semantics, and nothing's as well defined or agreed upon as we have here in the REST world. Here's where I propose a term. For the rest of time, people will know that the word RESTSockets was invented in Warsaw. And it means just putting your WebSockets right there in your API. Make it like another verb in HTTP and say, if you make a WebSocket connection to /API/todos, then you're just going to be getting streams, events, every time one of those to-do items changes. If one gets added, boom, an event comes down the WebSocket. If one changes, the payload comes straight to you. If one gets deleted, then you need to have a little bit more information in there to say that, oh, this thing was deleted. It's not like it was an update. And same if you do it to just /todos/ID, you'll get just the changes to that one item. On my personal preferences, personal biases slide, I said I like a framework where you get a class for your view, and then you have methods for get and put, delete. Well, let's make WebSocket just another one of those too, so it matches up with the way we're going to handle WebSockets in our API. And if you check out the repo for this to-do app, you can see how that's been implemented. I just want to look at detail of a couple of these methods. On the put, this is where we handle updating a to-do item. We pull the data from the request. We send a query to the database. Depending on how the database responds, we either say, great, I'm going to redirect you to the thing, or we say, sorry, that's not a valid to-do item. I'm a little self-conscious after this morning's and earlier afternoon's talk to be writing SQL directly in my view, but this was optimized for fitting on one slide and being clearly understandable, so only a little guilty. The WebSocket view on this same class is a little more complicated and a little more interesting, because instead of actually returning a response object, we need to not return. We're going to go into some loop that may never end, and every time something happens that's interesting to our consumer, we need to write it. We need to use self.ws.send and send some payload out on the WebSocket. Other than that, this should look vaguely familiar to that slide a few slides ago, where we had an iterator over events, and for each one of them here, we're either sending the payload, if it's one we're interested in, or if it was a timeout or something we weren't interested in, we're just going to send a ping over the WebSocket, and that lets us have a keep alive and a cleanup if the socket's dead. Cleanup actually turns out to be the most complicated part of this, because unless you try to send something, you're never going to know if the person went away. So you have to try and send stuff periodically. Let's demo this API. We have to-dos web, and we're running. Let's get another terminal over here, and another one here. And I'm going to connect into the database, and I'm going to make a thing. Well, I'll just show you, I do have that table there already with those columns we talked about. Insert into to-dos the thing, and I need SQL quotes. I need single quotes. What did I do wrong? Oh, I have to tell it what columns I'm talking about, obviously. To-dos, title, values, the thing. And now if I make a request, well, there it is. All these fields that we didn't provide were auto-populated. We have an ID, and now we can go get it from the database. To-dos, paste that ID, and we see it there. Let's make it a little prettier. There is the thing we just created. But that's boring. That's a REST request. We've all seen that before. Let's make it a WebSocket. For that, we use WSCat, which is like the WebSocket alternative to curl. Now we see the payload come back immediately, and we're also waiting. The thing hasn't finished, it's just waiting for any updates. Let's give it one. Let's say update to-do set completed equals true. And immediately we see something happen over here. We were told, hey, this thing was just marked completed, but it delivers it as the full payload. So we see the WebSockets and the REST API together on the same endpoint and kind of working according to very similar expectations. So we've done the Python layer on top of the Postgres layer. Let's go up one more doing that in reverse. Up one more and build a UI on top. Here it gets crazy because there are a million things to choose from and tie them together, and it's hard to know what's really maintained these days, or is this really the latest hotness? Here's what I chose for this one. I'm not going to say that this framework is necessarily better than the other on a lot of these choices. I will pick out two of the decisions that I made here and go into a little bit of detail, and that is on choosing React for this app and using a Makefile to tie it together as opposed to a lot of the other options out there. React, I see as having been a response to other frameworks that came up, especially Angular and Ember, where they were emphasizing two-way data binding. I have a model, and I have my view on the web page, and when I update one, the other one automatically gets updated. And updates could come from either side, and then they flow back. React says, well, that gets complicated. You might have 10 things on the page with relationships, and making them all flow between each other can become a real problem. You can get into a situation where you actually have circular dependencies, that you start updating one thing and it cascades all the way around and ends up updating itself. And React says, well, we can solve that if we just make our data flow one way. Say, we'll just have one place that events come in, they update a store of our data, and that just flows one way out to the UI. That worked really, really nicely with this architecture because we can say that one way that changes are going to flow into our UI is going to be the WebSocket. And if you want to click on something in the UI, mark one of these to-dos as completed, that's an AJAX call up to our REST API. That goes out, and it hits Postgres. Postgres updates it in the database. And that flows out back through the notify, and then from Python, it comes over the WebSocket into our app, and we see the update. Not just us, but everybody using the app sees the update at that point. And switching the React.js TodoMVC example over to this thing required just changing the one file in the to-do model, and the changes were pretty obvious, straightforward. I thought it was a good success and a testament to it fitting well with this kind of architecture. Make is old, and I consider that a virtue for a tool that needs to span the ecosystems of Python and all of its build tools, JavaScript and all of its build tools. I know it's not going to be superseded in 6 months by the next whatever beats out Gulp. There's one other piece of this that isn't getting as high a billing, but that is NodeEnv, which is a Python package you can install with pip, but then it gives you Node.js and NPM within your virtual env. And from there, this Makefile can use all of those JavaScript-based tools to do all the other things we need to build up our UI. So we just type make.js, and the whole JavaScript ecosystem we have bootstraps itself and gets built into the project. That is the top layer, so let's demo this UI. I was already running to-dos web over here, so if I bring up my browser here, of course, it was already updated because it was attached. We have the one to-do item, says do the thing. Let's make it 2 of these. Let's uncomplete that. Let's complete it. Let's clear all these. Let's add another thing. And of course, you see they're automatically updated in both places at the same time. But what I think is even cooler is not having 2 browser windows next to each other, because you've seen that with like Google Docs. But to come back here and actually drive this from our SQL prompt. Let's clear all these guys. Boom, it's cleared. Let's add another one. To-dos, title, values, and at. and we're done. And that leads us to a summary. How do we build real-time web apps with just Python and Postgres? Use Postgres triggers to notify your app when something happens. You don't have to poll, you don't have to refresh the page. Postgres can let you know. Because frameworks haven't yet been built in Python around this pattern, they have a lot of stuff we don't need, and not really doing the stuff we do, let's use as little framework as possible. I think the RESTSockets pattern of doing your WebSockets at the same point as your REST API endpoints makes a lot of sense. It saves you from having to invent new protocols. React fits nicely, and Make fits very nicely. And with that, we're open for questions. If there are any.
Hello.
Hi.
What a nice presentation. So I have a question. This framework looks very nice, easy to use, but what do you suggest to do when you are sitting under the corporate proxy that does not support streaming? How the whole architecture should change?
When you're sitting under the corporate proxy that doesn't support streaming. We had this at work, actually. We use a load balancer called Stingray. It's built by a Riverbed company, and they do not have good WebSocket support. In our case, we solved it by getting another proxy. So we set up an Nginx for our WebSocket apps. But architecturally, the other way that I solved this, as I mentioned, there's alternatives, other ways to stream. And in previous apps, before we were really getting into WebSockets, I actually use server-sent events, which you can look into. If you're bound to only using plain HTTP, they will work over plain HTTP. There's nothing fancy about the protocol there. It has its own gotchas, like you're subject to the max number of HTTP connections that the browser will make, which is 6 in Chrome and Firefox. And the dev teams have refused to lift that limit. So say you make 2 connections in your UI, which is what our app was doing. As soon as somebody opened the app in more than 3 tabs, it was totally unresponsive. They couldn't get back. I mean, the page wouldn't even load. And then I get bug reports saying, is Velociraptor down? I can't get it to load at all. And I always ask, how many tabs do you have open? Oh, and then they go back. So yeah, if your corporation doesn't allow WebSockets, they're just not quite up to having a load balancer or a proxy that can handle those, then we have to compromise.
Thank you.
Hi. So we know the story about n equals 1. Now, what happens if you have like 2 Postgres servers? I mean, like, I don't know, master, slave. Does that support, I mean, the pub sub thing, does that span across multiple servers? How does that work?
So this is another one we have. We have a sharded Postgres set up for one of our systems. And on that one, well, I could see 2 ways to do this. I'll tell you one we're using and another that I thought of. We, for the application in question, actually we have one listener process for each Postgres that listens to notifications. And instead of relaying them up into the browser, it's just forwarding them into RabbitMQ. So they're all funneling in that case. But you could also, if you're sharding your database at least, you say, well, a user's data, I take the user ID, hash it, modulo that over whichever, and find the shard. You could do the same thing to say, that's the Postgres I need to go to find the updates and subscribe. So I think, in the sharding case, that still works. On master-slave, I still think that works. However you're deciding whether you're connecting to the master or the slave to do your reads, you could be connecting to do your listens as well. There's a question way down here.
Here.
Thank you. Great talk. I just wanted to ask about that NodeEnv package. Have you encountered any problems with any NPM package while you were working, or do you know if the gulp works perfectly with it?
The biggest problem I've seen is when I was trying to use NPM packages for stuff I wanted to run in the browser. So if I go back to the Makefile, you'll see I'm using NPM for some stuff, like React tools and Uglify, I'm using Bower for other things. And the reason for that was NPM tends to assume that you're going to be using like require.js or AMD or one of these module loaders. I didn't really want to go there. Whereas packages that are being installed by Bower tend to be much more friendly to just being injected in your page with a script tag. That's why I've split it here, so that the pieces that I have to run at build time, I install with NPM because then I'm just running them in Node and they all work. The pieces I have to run in the browser, I use something else. I use Bower because they're better packaged for the browser generally.
Do we have any more questions? Seems like no. So thank you very much for this talk.